what are the 10 moats of NVIDIA? Why is NVIDIA able to defend its competitive advantage against all the competitors that are out there to create more chips, create more processing capacity? So we have companies such as Intel, AMD, TSMC, which is already partnering with NVIDIA, Tesla Dojo, Google Tensor Processing Unit. They all create their own chips. They try to be more efficient. They try to do more compute at a lower cost, right? Meta, Amazon, Sam Altman's chip company. Now we have the list of competitors is growing by the day. Why is NVIDIA able to defend its competitive advantage? So let's dive right into the mode. So for the first mode, so we will see 10 modes, but the first one of the most important, I first want to clear this misconception. Here, this picture is by NVIDIA, right? And they show how they go from a single chip, like a single GPU, they combine them to even a chip consisting of many GPUs that work together, that process the unique workload that is AI training and AI inference, that work together effectively, that have communication channels between those AI training chips. And so we have communication among these training chips, right? So we need to have efficient communication infrastructure so they can exchange the intermediary results in the training phase. We assemble them together, we package them together into larger and larger units, package those larger units together to assemble supercomputers, package those supercomputers together to assemble data centers, and then we sell the data centers, right? This is NVIDIA's competitive advantage. By the way, nothing in this video is investment advice. This should not be taken as investment recommendation or anything. It is just my own research, my own opinion. I own NVIDIA stock and I do some research and try to analyze its competitive advantage, and I just share my analysis with you, but I'm not an investment advisor, and everything I say in this video might be wrong. Okay, so NVIDIA is basically the engine of AI, as it says on the picture. And also, if you look at what Jensen Huang, the CEO of NVIDIA, says, people think that we build GPUs, but this GPU is 70 pounds, 35,000 parts. Out of those 35,000, 8 of them come from TSMC, the company that we identified as competitive before. The rest of them comes from different partners, different producers. They assemble it together at NVIDIA. It is so heavy you need robots to build it. It's like an electric car. Yeah, people don't think of it this way, but NVIDIA also produces products that are electric, like an electric car, like Tesla's electric cars, but it consumes more energy and it sells for a 10 times higher unit cost, right? Unit price. And yeah, sometimes between 2.5 and 10 times higher unit price or so. So they basically sell supercomputers. Yeah, people still think NVIDIA, they sell GPU chips or something, but they basically sell AI supercomputers, and they are the world's first company that does it. The world's first AI supercomputer company. So you can see the mode here. I think this is a beautiful picture. I took it from a site akashg.com, and you see they started with GPU, DPU, CPU, in 2012, 2014. They already saw that AI workload is done on GPUs. When I was a researcher in the AI space, it was already very evident to me and all my colleagues that everybody trains their AI models on GPUs. It is the most efficient way to do so. It is the fastest way to do so, the most cost-efficient way. It was the only way, the only way to do on GPUs. NVIDIA saw this very early, developed the CUDA programming language and programming framework with SDK, software developer kits, and so on. So they have a hardware advantage, they have a software advantage. There's competition, and they have unique customers. And basically all customers are all tech companies, all tech leaders are customers of NVIDIA. We will look into the different modes in a minute. Okay, so to recap, neural networks are backward programmed. So we give them the result we want, we give them examples, and they figure out a way to produce those examples. It's called Software 2.0, a term I think initiated by Andrew Karpathy, or at least popularized by Karpathy, the AI leader of Tesla, before he left Tesla, I think a year ago or so. And so it is like traditional software 1.0 is you write the software first as a software developer, then you test the software if it produces the result that you want. And AI is the other way around, right? You give them the result you want, the software writes itself, and then you just get the result you want for the input. And Jensen saw this very early. Like, as I said, like 10 years ago, when I was still doing research in the AI field, it was already very evident for all of us that NVIDIA is the company to watch out for. And he delivered now the first supercomputer to OpenAI. So without NVIDIA, we wouldn't see GPT-4, and we wouldn't see the wonders of artificial intelligence that we are seeing now. And let's dive into the two modes, hardware and software mode. Next, the hardware mode. First of all, let's take a look at the floating point operation, the scale we are talking now, right? Google, Meta, OpenAI, they use farms and farms of GPUs. Like, they don't use a single GPU, they use farms and farms. They combine those GPUs to bigger and bigger and bigger units, right? Into data center scale, so that they can train models. And how big are the models? The models might be 1.8 trillion parameters big, right? A single model for the OpenAI, which results in 30 billion quadrillion flops. 30 billion quadrillion floating point operations per second. The scale is massive, and we are just in the beginning. The models become larger, the data we throw at those models become larger. The number of floating point operations we need to throw at them to create next level AI models like Sora, like OpenAI's Sora, that can create text to video, or video to text, or maybe text to video with sound, and so on, or maybe physics engines and so on. So there is infinite command. The world around us is waking up, is awakening. Everything is waking up. We take dead earth, we take some metals from the earth that are dead, we give them energy, we give them AI training chips and inference chips, and we give them intelligence, and they are awakening. They are talking to us, they are walking the earth, they are doing work for us, physical labor, intelligent labor for us, and it is just waking up. And how does it wake up? It wakes up using AI compute, right? Again, this figure here. Good. So, and the latest hardware innovation is the Blackwell architecture. It was introduced in the keynote presentation we have all seen by Jensen Huang, and it is much faster, 5 times faster, and so on. So it will be used by all companies, basically all major tech companies. Next slide. NVIDIA has created a huge innovation engine. That's why they have this hardware mode. We are still in the hardware mode section, right? And like one teraflop is a quadrillion floating point operations per second. I'm not even sure if this is true, but it might be. Okay, and you see how it developed over time. We have seen not even 1000x. It was like a huge scale of AI training, and the bottleneck for GPT-4 training is currently communication bandwidth, believe it or not. And the Blackwell, the new architecture offered by NVIDIA, offers an 18x communication bandwidth compared to the previous infrastructure Hopper, right? So now NVIDIA has not only created AI training and GPUs, they already created communication among those GPU chips, because those chips from time to time they need to exchange data, right? If you compute something in your CPU and your GPU, you need to you get the result, you need to send the result somewhere, or it is just lost in the chip. And where do you send it? To other chips, so you can do follow-up computations with and your operations are not independent. Your operations depend on each other, right? You get the output and you feed the output back into another computational unit, and so on. You just keep doing it until you get the final result, the final model. And so communication, we basically have computation and we have communication as two important factors of AI training. And NVIDIA is basically the innovation engine that makes it happen, right? That optimizes the efficiency of AI training. And just to land with the words of one of the biggest competitors, Elon Musk, if your only defense against invading armies is a moat, you will not last long. What matters is the pace of innovation. That is the fundamental determinant of competitiveness. And I wanted to start this discussion of NVIDIA moats by just saying, okay, NVIDIA is a dynamic organism. It is an innovation engine. It is not only, like all moats we discuss here are like a static snapshot, but basically the culture of innovation at NVIDIA, the progress, the vision they had from like 20 years ago, seeing that AI training will be big, like betting the whole company on the AI, on the future of AI. These kind of moves, the talent they have, the innovation they produce day after day after day, this is the driver of new modes, of the next level modes, of the next decades of mode. Nothing is predictable. It's not predictable how the world will look in a decade or two with perfect accuracy. But we can already see the players moving fast in the new space, pushing the boundaries of what was deemed possible. And we've seen innovation with like GPU innovations, AI and deep learning innovation, advanced chip technology. Okay, so let's go on. Here you can see a quick timeline of innovation. In 1993, they started with 3D graphics, right? Then they focused on GPU. 1999. This is 25 years ago they started creating their first GPUs for gaming initially, but then they quickly saw that programmable GPUs is the way, and they designed the CUDA programming language or programming framework where they can program graphical processing units, GPUs, for general purpose tasks, so general purpose GPUs, right? And in 2012 they already focused on AI. This is 12 years ago, right? 12 years ago at the time of writing. So they were really early, and you can see how they made progress, how they basically scaled out Moore's law. So Jensen Huang already learned early that Moore's law will not continue forever, and you see it is flattening out the single-threaded CPU performance. But he basically fixed it or superseded it with a GPU accelerated computing disruption that has like 1000x the number of operations per second in 10 years. So it is basically it grew faster than Moore's law based on NVIDIA's accelerated computing framework. They produced more exaflops. So what is an exaflop? Exaflop is already an impressive amount of compute, right? So we have the Blackwell GB200 plus NVIDIA InfiniBand. So this is computation and communication hardware solution. It can generate 1.44 exaflops or 1,444 petaflops or 1,444,000 teraflops. And OpenAI will just increase the model sizes, right? This is like, this number of floating point operations, they are insane. It's very tough to imagine, to see what an exaflop is. But an exaflop is so many data centers, it's so much compute currently. It is unimaginary number of intelligence that is put into one exaflops. And OpenAI will just keep increasing model size. Not only OpenAI, but basically all tech companies, Llama, also Meta with its Llama model series, and so on. And both they will increase the model size and the input data. Why? Because of the AI scaling law. Because we have scientific proof that we have not reached the end of scaling, the end of scalability in terms of performance. If we throw larger models at the problem of training AIs, and we throw more compute at it on more training data, we get better performance. We have not reached the end of scalability. The IQ of AI models is just getting started, right? We are just in the early phase of AI. And GPT-6 will do text to video like Sora with sound, for example. And you just think about the insane AI compute this will generate. Why? Because video is much more data than text. Currently we have text-based models. But think of the internet. The internet, when it was still text-based, then the data, comparatively to today, the data used was marginal. It was very small compared to today. We have seen now that we stream videos, it is a joke. Like the text-based data in the internet is a joke compared to the video-based data and the sound-based data. And the same for AI training. The demand for compute will not only 1000x, it will probably million-x in the next decades or so. Yeah, so we will see many orders of magnitude increase in demand for AI compute. Obviously, it will also get cheaper. So we won't see a million-x in revenue for NVIDIA. And we will see more competitors, more technologies, and so on. So it is difficult to predict space. But NVIDIA has a long stream of future profits ahead. I think we can safely say this. Good. Then the CUDA and software mode. I've already talked about a bit about CUDA. Why is there a mode? So the CUDA is the programming framework so we can program against. We can program GPUs, obviously, and all these programmers that are already skilled in the CUDA programming framework, and the efficiencies introduced by the CUDA programming environment, the SDKs, the network effects, the developer networks effects. All of these create a mode that is difficult to capture by a new market participant. So if you would start out now as a competitor of NVIDIA, you would have to do your own CUDA. You would have to find your own developer community. You would have to do your own iterations on programming commands, for example. You would have to find your own developers creating documentation, discussing the pros and cons of different features. Like CUDA already has a huge startup adoption. So all emerging tech companies like Mosaic, ML, or OpenAI, they prefer NVIDIA's ecosystem for their operations. So overcoming this will be very, very challenging. And here we see that CUDA is actually more popular than ever before. So you see the Google Trends, for example, people search for CUDA. This is something that is very difficult to recreate for a new AI chip manufacturer, for example. There are some factors that preserve the dominance. I took this from somewhere. We will not go into this. I mean, you should understand by now that it's very difficult to. Actually, I give the references to all sources in the slide and at the end of this presentation. It is just very difficult to break the dominance of a programming framework. You can see it with Python. Nothing can stop Python, JavaScript, even Java, even the old languages. They are still very predominant. Why? Because it is difficult to break the dominance of a programming environment. People just get used to the environment. They don't want to change. They have their systems created in this language. So even very old death languages like COBOL are used in banking, right? Oftentimes these programming languages modes are unbreakable. Good, let's dive into the next mode, which is the fact that NVIDIA doesn't sell chips like AMD. So AMD is not really a competitor to NVIDIA. NVIDIA sells data centers. And I really want to stress this point. That's why I made it a separate point as well. So if you look at their market platforms, they have data center revenue, gaming revenue, professional visualization revenue, and automotive revenue. But currently, most of the revenue comes from data center. And you see, let's dive into this revenue a bit more. This I have already shown you. They go from chip to AI data centers. And currently, they have a monopoly. This is not even a mode, it's a monopoly on building AI data centers. There is no other company that not only builds AI factories, but sells them to other companies. So everybody who wants to do something with AI needs to partner up with NVIDIA. And we will see this partnership advantage. We will see it in this mode. The next mode is basically another mode, right? This one is just that they have the monopoly on just building. There is no other company capable of going from the chip, vertically integrated, from the chip all the way up to the AI factory, and packaging this as one huge, gigantic chip. So think of this, an AI factory, it's one gigantic chip. You put in data, you get out tokens. One gigantic chip that consists of myriads of chips that are able to do billions of quadrillions of operations per second to train general artificial intelligence. This is huge. I mean, this idea is just huge. It just has to be. General, we are at the dumbest, as collectively, we, as the world, as humanity, as a cyber biological system, organism that we are at the dumbest we will ever be. And in a few decades, we will be orders of magnitude smarter. Why? Because of those AI factories, because they give us the brains, the deep understanding of the universe we seek. Nothing can stop it. And one of the modes here is the partner and network integration. So NVIDIA has many partners. This is something you cannot bootstrap easily, right? If you are a new entrant in the space, you cannot just partner up with all companies, with all major companies like Google, Microsoft, Oracle, Dell, HP, Lenovo, and so on. So NVIDIA has already partnered with every single player in the technology universe. Every single player. There's not one tech company that doesn't partner up with NVIDIA one way or the other. AWS, the largest cloud provider, has a section. Let's look at it. AWS, NVIDIA. If I search for it, AWS. Like AWS currently runs most compute in their framework, but within AWS, you can access NVIDIA. AWS wouldn't, like customers demand NVIDIA. Customers of AWS, with EC2 instances, they demand NVIDIA chips. Many of the machine learning workloads within AWS run on NVIDIA chips. And what does it mean? Basically, it means, here, look at this graphic, it means that Amazon pays money to NVIDIA. They partner with NVIDIA. Alphabet partners with NVIDIA. Apple partners with NVIDIA. Microsoft with NVIDIA. Meta with NVIDIA. Tesla with NVIDIA. Think of it like a huge network. And interestingly, like not everybody partners with Meta, right? I wouldn't be so sure that Tesla purchases anything from Meta. I don't think so. Alphabet, probably they don't partner too much with Meta or Apple or Microsoft. But all of them partner with NVIDIA. NVIDIA is at the center of all technology companies and non-technology companies that use Microsoft. They are at the center of a huge partner network. Every AI and cloud leader partners with NVIDIA. And every other company that exists partners with one of those. So indirectly they partner with NVIDIA as well. It's like a network, the network effect. You couldn't pull out NVIDIA at this point without affecting all companies on the planet, negatively affecting. That's why all companies on the planet are somehow interested in keeping NVIDIA in the network. And other competitors, it is just very difficult to get to this position, or if it was easy, everybody would do it, but everybody cannot do it. But NVIDIA is already here, it's already proving it out, right? They have also a partner network locator, for example, here, this tool you can play around on the network side with partners and consultants and so on, where you can just search your partner, and you can see like there are so many partners that it is a huge network. It is a network of partnerships that gives its strength to NVIDIA, and this definitely is one of the biggest moats of NVIDIA. The fact that they are the leaders in AI and high performance computers, they are used by hyperscale and cloud computing providers and over 40,000 companies. NVIDIA powers 75% of the top 500 supercomputers, so like 400 or so of those supercomputers are powered by NVIDIA. The fact that they do all of that in unbelievable scales means that they have the highest performance per dollar spent. They have the highest efficiencies in chip design and chip creation. They have the greatest efficiencies of scale because they have the biggest scale. It's a huge moat that is very difficult to overcome by a company that has only 1% of its size. Because if you 100x your output compared to your next competitor, then your cost per unit produced are significantly smaller than your costs than if you would have a smaller efficiency of scale, a smaller scale. So these efficiencies of scale, it's a very conservative mode. Every conservative business and analysis would see this mode immediately. The next mode is simply the ecosystem beyond CUDA. We have already seen like ecosystem mode. Maybe you could merge those two, but I wanted to have CUDA as a separate point because CUDA is more like a programming framework. And then you have the remaining ecosystem of NVIDIA, which creates a dependency on the NVIDIA ecosystem. So if you can, for example, look at GPU accelerated libraries, languages, APIs, performance analysis tools. So if you're a developer, you want to create your own AI models, you need to analyze those models. You need to analyze at runtime. Okay, if you train your model for months on end, right? Your model trains for months. You want to see what is going on under the hood. There will be some mistakes. And in order to not lose your intermediary states, for example, intermediary model states, you need to debug it. You need to capture intermediate results and so on. So all these little things are already solved by NVIDIA and provided to them, and provided to the customers that actually buy those AI training data centers. And this ecosystem is just very powerful. It's unbreakable as well. We have already discussed this. They are the first to market in 1999. They already created like GPUs and these kind of ideas and accelerated computing. And the early investments have given them a first mover advantage. This is also a traditional mode. Being first to market on itself is not a mode, but I always think of it this way: like the mother of all modes strategically is our network effects. And network effects take place with two variables, growth and time. So you need to have a growth rate because your network grows, say, by 5% every year or 20% every year. It depends on your network. It grows, maybe the developer network grows at 5% per year over a certain period of time, over certain years. And if you see like the exponential increase of your network, the exponential improvement is a function of time as well. It is a function of time and the growth rate. And the growth rate, you need to keep stable over a certain period of time in order to benefit from the exponential improvements of this growth. And time is basically here is one of the modes that NVIDIA had. It had most time to grow its CUDA reach, its developer reach, its integration with 15,000 AI startups in 2023, its GPU accelerated applications. They had time to grow. It is like proof of time, proof of work, right? They have proven they can accelerate workloads using GPUs. They can create real-world applications. The applications that build on them, every single application is a small proof that NVIDIA creates value in the marketplace. And it is not so easy to like if you want to overcome this mode, you would have to spend 20 years yourself proving that you can maintain your growth rate over time. NVIDIA has already done it, and the Lindy effect suggests that if they have already done it for 20 years, they are likely to do it another 20 years. If you as a newcomer company do it for 2 years, then maybe it is expected that you will do it another 2 years before you fail, right? Or before, yeah. So this is called the Lindy effect. It's a very popular effect in psychology. Good. Then the next mode is brand strength. Very simple, very traditional kind of mode, but a very, very real mode as well. So if you want to publish an AI paper in the time between 2018 and 24, I took 2018 because I already published AI papers in this kind of year, and it was true. Like, you just cannot publish a paper without using the word NVIDIA. Try to copy this. If you're a traditional company, try to copy it. It is impossible. You cannot even bribe researchers to use your term. Researchers as a general community, they are not easy to bribe. They just use NVIDIA because NVIDIA is the best, because it's like a meme. If you're an AI paper publisher, you better use NVIDIA in your evaluation section, because it just gives you a little bit of edge. The reviewers, they read the term NVIDIA and they already think you are more sophisticated because you are using the term. This brand recognition is very real, and it means that every researcher that ultimately decides which compute infrastructure is used, and the researchers then will get hired by Google Brains, and the Google Brains researchers, they now want the NVIDIA GPU infrastructure. So they tell their bosses, we need an NVIDIA cluster, and the bosses, they just order them. The bosses don't understand it, right? They don't understand what kind of infrastructure is best. But if everybody is already, like if the brand NVIDIA is already so strong that you as a developer, you just need NVIDIA. You don't care about the money spent. You just want the best performance. And so you tell your boss you want an NVIDIA cluster, and it is objectively the best performance-wise. They also have the cost benefits, right? We have discussed before the efficiencies of scale. So NVIDIA is the best brand with the lowest cost for AI training with the fastest time. So that's why. Yeah, that's why you just like this brand. So here's an example. Maybe let's have an example. In the paper, attention is all you need. Very fitting for this kind of mode, right? The brand and attention mode. In the paper, attention is all you need, that created this whole transformer architecture with OpenAI, with the best AI researchers in the world that also work for the big tech companies. If you go to section 5, the training and evaluation section, you see at 5.2 hardware and schedule, we trained our models on one machine with 8 NVIDIA GPUs. Okay, so they are using NVIDIA. Everybody is using NVIDIA in AI research. So this is a very real mode that is unbreakable by a new market participant. Good. Then have a look at another general mode that is also powerful. If you attract the best talent, we create the best products, we sell most unit, we make most profit, we increase the value of our stock options, we attract better talent. this kind of general talent cycle, it is a mode for many of the tech companies, but it's also a mode for NVIDIA. And the new market entrant would have to overcome this mode. And NVIDIA, they attract a certain breed of highly intelligent, highly practitioners, and who are also willing to work very hard. So Jensen Huang, the CEO of NVIDIA, he's a hard worker. He is a multi-billionaire, but he is still working whole day, whole week, 7 days a week, and so on. So I don't know. So he's just a very, very hard worker, and it is he has created a culture of hard work for highly innovative areas. And if you are not a hard worker, you will not survive at NVIDIA. And this attracts more and more hard workers. They have access to the best talent, and having access to the best talent ultimately is what a company makes out, right? A company is just a selection of human beings that leverage their skills, maybe enrich their skills with AIs nowadays, and leverage their skills up, their abilities, their capabilities to generate something with automation, and putting it all together to create some kind of product that is then purchased. And the product they sell is just, I think it's the most important product that is currently produced. Even more important than self-driving cars, right? Because it's more baseline, more foundational to create the AI factory that gives us intelligence. Okay, so we can see, like, you can check out some talents, what they are talking about NVIDIA. Many would agree that it's a great place to work. So this is kind of a mode that is also unbreakable. So if we put it all together, NVIDIA is first to market, low cost AI training and inference, infrastructure AI software provider. They have leadership in software and hardware. We have seen CUDA tools, we have seen the partner network, we have seen the tools and ecosystem networks. So we have many network effects at place working together to create the most powerful brand, so that they get more market attention and can maintain their monopoly in creating, building, assembling, maintaining and selling AI factories at scale. And I think it's an unbreakable combination of modes that creates one of the strongest companies, if not the strongest company on the planet. Thanks for watching. If you want to stay tuned, then subscribe to this channel, subscribe to my free email newsletter. Just go to Finxter.com. You can just subscribe at any form. I will keep you updated so you can be on the right side of change. We also have courses for AI practitioners, like highly relevant courses on the Finxter Academy. So let's open up the Academy. Here you can check out our courses. Just go to academy.finxter.com. You can check out our courses on, for example, how to build multi-agent teams and systems with LangGraph, fine-tuning OpenAI, creating customized models so you can scale up your value creation, your own value creation for your own, say, one-person startup at home. You can, we teach you how to use Google's APIs to create AI applications. We show you the basics of prompt engineering with drag and drop editors like AutoGen Studio. How you can use OpenAI's Whisper models to create voice recognition and integrate voice recognition in your Python apps. We show you how to master OpenAI API, so how you can access intelligence in your applications. And all these beautiful things you can do as a developer today to create the most powerful applications with only a few lines of code, very low cost, but very high intelligent applications. So check out academy.finxter.com. These are paid courses, but they are worth it. You can double your value to the marketplace just by paying $100 or so per year. I don't even know how much they cost. Maybe they are currently reduced price, but it's very low cost, high gain investment. So become a member. You can also become a YouTube channel member. Just go to Katana level or above, so you can access all Academy courses as well. Thanks for watching. Subscribe to the YouTube channel, subscribe to the podcast, and see you in the next video. Bye.